Thank you very much, Robert, and thank you to EFELA for the invitation. You know, the introductory remarks and the speech of Peter Cameron we heard all very inspiring. We learned a lot, and we will learn much more with the other speakers. And Peter, you addressed 3 questions, and you gave us a very broad picture of energy law in a time of competing policy priorities. I will only focus on one question, so I will try to focus on the digital transition and the effect it has on the green transition. We are now facing 2 revolutions, the green revolution and the digital revolution. And those 2 transitions are not parallel. They are really strictly intertwined each other. Artificial intelligence nowadays is more and more integrated into the operation and governance of energy infrastructure, from predictive maintenance of grids and pipelines to optimization of renewable energy dispatch to demand-side management in smart grids. AI is nowadays reshaping the energy sector. But AI is both a driver of efficiency and also a source of new risks of biases, errors, and opacity. Also, as it has been underlined today, AI systems require an increasing amount of energy for data centers, data training, cloud services, and therefore they risk to undermine the decarbonization goals. So the question I would like to address is, how should we govern the digital transition so that it supports and not undermine the objectives of the European Green Deal? Let's start from what have been said. I appreciate very much also the introduction of Xala Gondola. I hope I pronounce the name correctly. The potential of artificial intelligence of the digital transition in the energy sector. It's well known. It runs along 3 axes. First of all, energy efficiency. Algorithmic tools optimize electricity grid by forecasting fluctuations in renewable energy production and thereby facilitating the integration of intermittent sources such as wind and solar, and guaranteeing balance between supply and demand. Since renewable sources production fluctuates, forecasting is necessary both for scheduling and the demand and supply part, so balancing the network, also for long-term planning. Good forecasting allows operators to decide where and when to install new green plants. And in all these sectors, artificial intelligence can offer a very important help. So artificial intelligence would optimize consumption. Smart meters, dynamic pricing would allow transparency for end users and cost savings as well. Regulatory compliance, automatic monitoring of emissions and energy consumption supports the enforcement of environmental and climate legislation. So all these possibilities are not hypothetical. They are really, and they are being already deployed. And therefore, it is no doubt that AI could help to achieve the objectives of the Green Deal and of the Fit for 55 package. But we cannot only see the positive effects of digitalization and of artificial intelligence. We must verify under which legal conditions and with which safeguards digitalization can be made consistent with fundamental rights, with market fairness, and with environmental sustainability. So let's give a look to the flows, the challenges posed by digitalization, so the digital revolution. First of all is the features of AI systems, opacity and accountability. As we all know, traditional algorithms are quite simple. They are rules which can be followed quite easily. AI doesn't work in a traditional manner. AI is based on analysis of large amount of data and creates automatically always new algorithms. So the main feature of AI systems is that they have a large degree of autonomy and opacity, and hence the famous comparison with a sort of black box. And this creates some problems. Peter Cameron said that in energy sector there's an increasing amount of disputes because someone took a certain decision affecting the interest of other operators. But when that decision is based on the advice of an AI system, then it could be quite difficult to understand where the liability lies. The operators take important decisions affecting business and consumers, such as load shedding or curtailment of renewable generation, or price setting in wholesale markets. And the lack of explainability of such decisions poses significant challenges both for regulators and also for courts. And this calls for greater transparency in AI system and algorithms. Also, energy infrastructures are critical assets, and their proper functioning is necessary not only for economic activity, but also for national security. And the use of AI creates new challenges, data biases, manipulation of the system could disrupt the grid stability and could compromise energy supply. And also, again, algorithmic opacity would, make it more difficult to find out responsibility for those decisions. And therefore, we face new issues on how safety standards and liability frameworks should evolve to address the specific risks posed by AI-driven decision making. Then we have issues with data governance and privacy. Smart meters and such devices gather an increasing amount of data. And those data are shared between operators, and therefore new issues concerning compliance with the GDPR will arise in connection to the increased use of AI system. Then we have issues concerning cybersecurity. Digital networks are always exposed to cyber attacks, and AI-controlled systems intensify this risk. Because from one side, AI systems may improve detection of cyber threats, but on the other side, they create new attack surfaces. So cybersecurity will be a very important issue to be addressed to guarantee the proper functioning of our energy system. And then we might have issues of non-discrimination. We know that artificial intelligence system may be biased because of design errors or also flaws in the data used in the learning phase. And these mistakes that may be made by AI system could end up in creating discriminations when AI is based for pricing decisions. And also, finally, the environmental impact of AI. Marinella explained to us how much data center consume in energy. It has been calculated that the energy consumed by IT equipment accounts for approximately 4% of greenhouse gas production, which is a lot compared to 2.5% of the greenhouse gas produced by air traffic. And it has been calculated in 2022, 3 years ago. Google published a report indicating that it used 25 billion liters of water to cool down its data centers. Therefore, it's not surprising that Marinella and many others are very much concerned about the environmental impact of AI. Now we have a regulation, the AI Act, which is the first attempt in the world to regulate artificial intelligence on an horizontal basis. The AI we all know, is based on a risk approach. So the idea is to identify different AI systems and diversify the requirements of those systems in the base of the risk they pose to fundamental rights. Therefore, there will be systems that pose unacceptable risks, like, for instance, social scoring, and they are prohibited. Systems that pose minimal risks, and they are subject to no requirements except some sort of transparency when we talk to a boot or those automatic device. It is important that we understand that we are talking to an AI system and not to a human being, but no further requirements are posed by the AI regulation. And for those systems that instead pose high risk, the legislator, European legislator, has imposed quite stringent obligations. And of course, AI systems deployed in critical infrastructures like energy are classified as high-risk systems. So the classification of grid management, safety monitoring, consumer-facing AI application as high risk is very important. This entails a number of obligations, not only for the developer of the AI system, but also for the user. Obligations of conformity assessment, risk management, documentation, human oversights, and also fundamental rights impact assessment. Will the AI Act suffice to address the risks posed by the increasing use of AI systems in the energy sector? This is an open question. Artificial intelligence has two phases, has a great potential to accelerate the green energy transition, but at the same time, it introduces new vulnerabilities that cannot be ignored. AI can optimize grids, can give more power to consumers, support compliance with global goals, but it raises issues of opacity, biases, and so on. And, from the environmental side, as we have seen, it raises a question of how a tool designed to help decarbonization at the same time risks increasing energy demand. So in all this, I believe that the Artificial Intelligence Act is a milestone by classifying AI systems in critical infrastructure. It acknowledges the importance of energy infrastructure and the need of strong guarantees in this section. But as Peter Cameron said, the application of AI regulation will not suffice. What is necessary in the field of energy is an integrated approach where artificial intelligence law, energy law, data protection, cybersecurity law rules work together in approach of the Green Deal. So I believe that nowadays an important challenge is to ensure that technological progress serves sustainability and fundamental rights. Only in this way will the green and digital transition reinforce rather than undermine one another. Thank you.